So let's look at the proof of the side-side-side congruence theorem. So suppose that we're given two triangles, A, B, and C, and D, E, and F, and we know that we have this correspondence between the sides, that we know that AC is congruent to FD, we know AB is congruent to EF, and we know that BC is going to be congruent to ED. Now what we want to show is that these two triangles actually in and of themselves are also congruent. So let's take a look and see how that proof might go. So from the protractor postulate and the continuity postulate, we know that we can construct a ray emanating from D, and this ray is going to emanate from D so that the angle that we have between B, C, and A is going to be congruent to the angle that we have between D, G, and E. So we know that this angle is actually going to be congruent to this angle. So what we can do from there then is to find a point on this ray DG, so we can find this point H, so that the length of the segment DH is actually going to be congruent to the length of the segment AC. So it's going to be congruent to the segment AC. It's also going to be congruent to the segment DF. Okay, so that's going to be our point H. So now if we complete this triangle and we draw the line segment between H and E, what we notice now is that our triangle ABC is going to be congruent to our triangle D, E, and H by the side-angle-side congruence theorem. Because we know that this side is congruent to this side, we know that this side DH is congruent to AC, and we know that the angle in between them is going to be congruent. And so that gives us that the triangle DEH is going to be congruent to our triangle ABC. So now what we want to do is to draw this line segment between F and H. Now when we do that, we get this triangle DFH, and that triangle, if we kind of highlight that one, that triangle is going to be an isosceles triangle because we know that this side is going to be congruent to that side. And so by our isosceles triangle theorem, what that means is that this angle is actually going to be congruent to this angle, so that the base angles are going to be congruent. And so kind of likewise, looking at this triangle that we have here, because we know that EH is going to be congruent to EF, that also gives us an isosceles triangle. And so we know that those two base angles are also going to be congruent, again, by our isosceles triangle theorem. So now what we want to look at is the sum of those two angles, so the sum of our base angle here and our base angle here, to give us this larger angle DFE. And also if we kind of look at the same angle down here, we look at DHE, because those two angles are made up of two other congruent angles, then that tells us that the larger angle must also therefore be congruent. And so now if we look at the triangle here and the triangle here, so that we can turn off our smaller angles. We don't need those anymore. So that if we look at the green triangle and the red triangle, we also know that those are going to be congruent by the side-angle-side congruence theorem. So we know that the angle is going to be congruent, and the sides on adjacent to that angle are going to be congruent, and so the two triangles, the green triangle and the red triangle, are going to be congruent by the side-angle-side congruence theorem. And that was really exactly what we needed, because now we know that the triangle ABC, by its construction, was congruent to triangle DHE. And so we have the green triangle congruent to the red triangle congruent to the triangle that we wanted to show was congruent to the green triangle. And so by one of our common notions, the triangle ABC therefore is going to be congruent to the triangle DFE, and therefore showing the side-side-side congruence theorem.